Good morning. Now we are passing to oxidation reactions of aldehydes and ketones. Oxidation of aldehydes and ketones. Oxidation of aldehydes and ketones. First one is oxidation with strong oxidizing agents. Oxidation with strong oxidants. When aldehyde is RCHO is oxidized with strong oxidizing agents like acidified KMnO4 or alkaline KMnO4 or acidified sodium dichromate, etc. So when aldehyde is oxidized with KMnO4 in acid medium or KMnO4 potassium permanganate in basic medium or Na2Cr2O7 in acid medium, or we can use our John's reagent CrO3 H2SO4. This is John's reagent, okay, or CrO3 in H2SO4, or we can use chromic acid H2CrO4. Okay, so if we oxidize aldehyde with any of the strong oxidizing agents like KMnO4 in H plus or KMnO4 in alkaline medium or sodium dichromate in acid medium or John's reagent CrO3 H2SO4, this is John's reagent, or you can use chromic acid H2CrO4. What will happen? Aldehyde will be oxidized to the corresponding acid. That means RCHO will be converted to RCOOH. Okay, example. CH3CHO acetaldehyde on oxidation with any of the strong oxidizing agents. What will happen? If you are taking 2-carbon aldehyde, you get an acid with 2 carbon, that means CH3COH. If you take aliphatic aldehyde or aromatic aldehyde, suppose you are taking benzaldehyde CHO on oxidation with any of the strong oxidizing agents, what will happen? The CHO group will be oxidized to COH. Okay, COH. So keep it in mind, when aldehyde is oxidized with strong oxidizing agents, it will be converted to the corresponding carboxylic acid. But at the same time, you can see that ketones, okay, R, C, double bond O, R, ketones under ordinary conditions will not undergo oxidation. So, ketones will not undergo oxidation under ordinary condition. That means ketones will not undergo oxidation under normal condition. But on prolonged heating, it will undergo oxidation. So, keep it in mind, aldehydes will undergo oxidation into the corresponding carboxylic acid if we use any of the strong oxidizing agents, but at the same time ketones will not undergo oxidation reaction under normal conditions. Okay, so the first one is oxidation with strong oxidants or strong oxidizing agents like potassium permanganate, sodium dichromate, chromic acid, or John's reagent. Next, second one is oxidation with mild oxidizing agents. So second one, oxidation with mild oxidizing agents, mild oxidants. First one, yeah, oxidation with Tollens reagent. This is a mild oxidizing agent. So first one is oxidation with Tollens reagent. Tollens reagent is ammoniacal solution of silver nitrate. What is Tollens reagent? Ammoniacal solution of silver nitrate. That means how will you prepare Tollens reagent? By dissolving silver nitrate in water. So Tollens reagent is prepared by dissolving silver nitrate in water, then followed by adding NaOH solution and then aqueous ammonia. So how do you prepare Tollens reagent? What is Tollens reagent? Ammoniacal solution of silver nitrate. How will you prepare Tollens reagent? By dissolving silver nitrate in water, followed by adding NaOH solution and then adding aqueous ammonia. Okay, now so let us discuss the oxidation of aldehydes with the Tollens reagent. So keep it in mind, using Tollens reagent we can oxidize aliphatic aldehyde as well as aromatic aldehyde. Both aliphatic and aromatic aldehydes can be oxidized with Tollens reagent. So let us take some examples for oxidation with Tollens reagent. So RCHO aldehyde oxidized with Tollens reagent. Tollens reagent can be represented as AgNH3 twice twice plus OH minus. This way you can represent Tollens reagent AgNH3 twice or plus OH minus Tollens reagent. So keep it in mind, aldehyde when oxidized with the Tollens reagent, you can see that this aldehyde will undergo oxidation and it will change into the corresponding carboxylic acid. That means RCOOH, carboxylic acid or carboxylate ion. You can write it as RCO minus, or you can write it as RCOH. And another important point, you can see that so RCHO is oxidized to RCOH, aldehyde is oxidized to carboxylic acid. At the same time, our Tollens reagent, this is our Tollens reagent, this Tollens reagent will be reduced to metallic silver. Okay, so what will happen to the Tollens reagent? This Tollens reagent is reduced to metallic silver, and this metallic silver will appear as a silver mirror on the walls of the test tube, So once again I am repeating, aldehydes on oxidation with Tollens reagent, aldehydes will undergo oxidation and will get the corresponding carboxylic acid. At the same time, the Tollens reagent is reduced to metallic silver, and this metallic silver will appear as a silver mirror on the walls of the test tube. So, and keep it in mind, this is a test to distinguish between aldehydes and ketones, because as I told you, under ordinary conditions, ketones will not undergo oxidation. So if you take a ketone with the Tollens reagent, what is that? No reaction, or you can say no silver mirror. So actually this oxidation with the Tollens reagent is a test to distinguish between aldehyde and ketone. What is the test? When aldehyde is treated with the Tollens reagent, what will get? We can see that a silver mirror is forming on the walls of the test tube, and at the same time, if you take a ketone and if you are treating a ketone with the Tollens reagent, we won't get a silver mirror on the walls of the test tube. That means only aldehyde is oxidized to carboxylic acid, and the same time our Tollens reagent is reduced to silver. But ketones will not undergo oxidation reaction, and actually this is a test to distinguish between aldehyde and ketone. And sometimes a question may ask like that, how will you distinguish between acetaldehyde and acetone? Suppose a question is like that, how will you distinguish between acetaldehyde and acetone? So what is the answer? You have to write the test is a test with Tollens reagent. When acetaldehyde is treated with Tollens reagent, we get a silver mirror. But acetone, since acetone is a ketone, CH3COCH3, when acetone is treated with Tollens reagent, we will not get a silver mirror, and the reason is very clear, because aldehyde is oxidized to the corresponding carboxylate ion, and at the same time what will happen to our Tollens reagent? The Tollens reagent is reducing to silver, okay, metallic silver, okay. But in the case of ketone, this reaction will not happen, okay. Another example, so if you take a particular example, you can see that let us take acetaldehyde. Let us take acetaldehyde, CH3CHO, CH3CHO, when reduced with, when oxidized with silver, Tollens reagent, AgNH3 twice plus OH minus, what you will get? You get CH3CHO will be oxidized. This will undergo oxidation. Aldehyde will undergo oxidation and you will change into carboxylate ion, CH3COO minus, or you can write CH3COH. You can write CH3COOH corresponding carboxylic acid. At the same time, this is our Tollens reagent is undergoing reduction, and Tollens reagent will be converted to metallic silver. This is appearing as a silver mirror on the walls of the test tube. Another example, if you take aromatic aldehyde, if you take benzaldehyde react with the Tollens reagent, AgNH3 twice plus OH minus, okay, what you will get? This acetaldehyde, the benzaldehyde, this will undergo oxidation and you will we will get benzoic acid. CHO group is converted into COH, and at the same time what will happen to our Tollens reagent? This Tollens reagent is reduced. This will undergo a reduction, oxidation reduction reaction. Tollens reagent is reduced to metallic silver. And now if you take a ketone, if you are taking CH3CO CH3 acetone, what is this? This one acetone, CH3CO CH3 propanone, acetone is treated with Tollens reagent AgNH3 twice plus OH minus, what is that? No reaction, or you can write no silver mirror, because under ordinary condition ketone will not undergo oxidation. So actually this is a test to distinguish between aldehyde and a ketone. Okay. So oxidation with mild oxidizing agents. First one is oxidation with Tollens reagent. Tollens reagent is ammoniacal solution of silver nitrate. Both aliphatic aldehyde and aromatic aldehyde will undergo oxidation with the Tollens reagent, and Tollens reagent will be reduced to metallic silver, but ketones will not undergo oxidation. Now second example, second reaction, oxidation with another mild oxidizing agent is that is oxidation with fehling solution. Okay, oxidation with fehling solution. Fehling solution is alkaline solution of cupric ion complexed with tartrate ion. So what is fehling solution? It is alkaline solution of cupric ions complexed with tartrate ions. Okay, complexed with tartrate ions. How will you prepare fehling solution? Fehling solution is prepared by mixing copper sulfate solution, which is known as fehling solution A, with alkaline solution of sodium potassium tartrate, which is known as Rochelli salt, or fehling solution B. So how will you prepare fehling solution? By mixing copper sulfate solution solution. This is known as filling solution A. Filling solution A. Filling solution A with alkaline solution of sodium potassium tartrate, tartrate, which is known as Rochley salt, Rochelle, Rochley salt, or it is also known as filling solution B, filling solution B. Okay, this way we are preparing filling solution. How will you prepare filling solution? By mixing copper sulfate solution, which is known as a filling solution A, with alkaline solution of sodium potassium tartrate, which is known as Rochley salt, or it is also known as filling solution B. Or in a simple way, you can see that filling solution is prepared by mixing filling solution A and filling solution B. Okay, now we can see that only aliphatic aldehyde, this is very important, using filling solution, only aliphatic aldehyde can be oxidized into the corresponding carboxylic acid, and aromatic aldehyde cannot be oxidized with filling solution. So only aromatic aldehyde oxidation with filling solution. What is that? Only aliphatic aldehyde can be oxidized to the corresponding carboxylic acid. That means CH3CHO acetaldehyde. This is aliphatic aldehyde, CH3CHO, when oxidized with the filling solution. See, look at here, how will you represent the filling solution? Cu2 plus and OH minus. This way you can represent filling solution. This is filling solution. Okay. On oxidation, as we discussed earlier, this aldehyde will undergo oxidation. Okay, the aldehyde group will undergo oxidation. That means CH3CHO is oxidized to the corresponding carboxylic acid or carboxylate ion. What we will get? CH3COO minus, you can write, or you can write CH3COOH. At the same time, plus this filling solution will be reduced to red brown precipitate of cuprous ion, that cuprous oxide, that means Cu2O. This is red brown precipitate, red brown PPT. Okay, so this is another test to distinguish between aldehydes and ketones, because ketones cannot be oxidized with filling solution. And one more distinction, what is that? This is a test to distinguish between aliphatic aldehyde and aromatic aldehyde. What do you mean by aromatic aldehyde? If you take benzaldehyde, this is CH3CHO, benzaldehyde with filling solution, Cu2 plus, OH minus, what is that? No reaction, or you can say that no red brown precipitate, no red brown PPT, no red brown PPT. So this is very important. Oxidation with filling solution. What is that? Filling solution will oxidize aliphatic aldehyde into the corresponding carboxylic acid, and at the same time filling solution itself will be reduced to red brown cuprous oxide. Filling solution will be reduced to red brown cuprous oxide. This reaction is given by only aliphatic aldehyde. If you take aromatic aldehyde with the filling solution, no oxidation reaction. Filling solution cannot oxidize aromatic aldehyde into the corresponding carboxylic acid, and hence the filling solution will not be reduced into the corresponding cuprous oxide, and hence we won't get any red brown precipitate. Similarly, if you take a ketone also, ketone with the filling solution, again no reaction, no reaction, no red-brown precipitate. That means aromatic aldehyde and ketones cannot be oxidized with fehling solution. Only what is that? Aliphatic aldehyde is oxidized with the fehling solution. Okay, clear. So this is a test fehling solution. This is a test to distinguish between aliphatic aldehyde and aromatic aldehyde, and also it is a test to distinguish between aliphatic aldehyde and ketone. Okay, and let us see few points. Look at it here. When I have discussed about Tollens reagent, one more points you have to remember. I am going back to Tollens reagent. Tollens reagent is Tollens. This point coming under oxidation with the Tollens reagent. Okay, Tollens reagent. Tollens reagent is used for selective oxidation of aldehydes. Okay, what do you mean by selective oxidation? Tollens reagent can be used for the selective oxidation of aldehydes. That means, look at it here. If you have okay, this is your compound, here it is CHO and here it is OH. So you can see that there is a CHO group, aldehyde group, and this is a secondary alcohol group. Okay, here it is this OH attached carbon, this carbon is attached to two other carbons, so this is a secondary alcohol. And if you use Tollens reagent Ag, NH3 twice plus OH minus, you can see that only the aldehyde is oxidized to the corresponding acid, but the secondary alcohol will not undergo oxidation. And we know that if you are using a strong oxidizing agent, we have studied that secondary alcohol is oxidized to a ketone. Secondary alcohol will be oxidized to a ketone. But here, if you use Tollens reagent will not oxidize this alcohol. This secondary alcohol will not undergo oxidation. This secondary alcohol will not change into a ketone group. It will not change into a double bond. It will not change into a ketone. Only the CHO group will be converted to COH. So look at it here. The OH group remain as it is. It will not be affected, but the CHO group will be converted to COH. And what will happen to the Tollens reagent? This will be reduced to metallic silver. Okay. So keep it in mind, this is selective oxidation. That means Tollens reagent will oxidize only the aldehyde group to the corresponding acid, but the alcohol group is not affected. That is very important. Another example for selective oxidation. Look at it here. If you take this aldehyde CH3, CH, double bond CH, single bond CHO, on oxidation with the Tollens reagent, on oxidation with which one we are using? Tollens reagent. Okay, look at here. You can see that here is a double bond, here is a double bond, and here is a CHO group. You can see that if you use Tollens reagent for the oxidation, you can see that the CHO group is oxidized to the corresponding acid, and the double bond is not affected. And what we get? We get CH3, CH, double bond CH, and what will happen to CHO? CHO group is converted to COH. The double bond is not affected. So this point you have to remember. What is that? Tollens reagent is used for selective oxidation. Tollens reagent will oxidize only the CHO group. In the first case, it will not oxidize the OH group. Okay, only CHO group is converted to COH, and in the second example, you can see that the double bond is not affected. Only the CHO group is converted to COH. Okay. So we continue with next class. Thank you.